Hi guys, this is O-Level Chemistry, paper 12, June 2022, question 21. 25 cm cube of 1 mole per dm cube hydrochloric acid reacts with 10 grams of solid to produce a gas. The solid is in excess. Okay, this makes the HCl the limiting reactant. The graph labeled first experiment shows the volume of gas produced over time. Okay. Graphs P and Q show the volume of gas produced under different conditions. Which changes in conditions produce graphs P and Q if all other conditions are kept the same? Okay, so graph Q shows that a volume of gas that is produced is lower than the first experiment. That means if solid is kept in excess, the acid used is in limited quantities. So we have reduced the number of moles of acid used, right? So that is why we have lesser volume of gas produced. Whereas graph P shows that the same volume of gas is produced. So we have not changed the moles of gas, but the dotted line indicates that the volume of gas produced is more quicker. So the larger amount of gas is produced in the lesser amount of time, but the overall amount of gas produced is the same. So the reaction is quicker. So when would the reaction be quicker? When this would be at a higher temperature, because increase in temperature increases the rate of reaction. So let's look at the options. P uses a catalyst and Q has a lower temperature. No, lower temperature will not result in lowering the volume of gas produced. So this is wrong. P uses 25 cm3 more concentrated acid. No, the moles of acid remains the same. That is why the volume of gas produced is the same. P uses a higher temperature. Yes, this part is correct. And Q uses 25 cm cube of more dilute acid. So the volume is the same, 25 cm cube, but it's a more dilute acid. That means the moles are less. If the moles are less, then the volume of gas produced would be less. So this is the correct answer. Option D, P uses smaller pieces of solid and Q uses larger pieces of solid. That will have no effect on the volume of gas produced. It will only have an effect on the time taken for to reach that volume. So option D is also wrong. So based on our conclusions, option C is the correct option for this question. Question 22. Nitrogen dioxide is a dark brown gas that decomposes as shown in the equation. The diagram shows a glass flask containing a mixture of three gases. The mixture is pale brown. Okay. More oxygen is forced into the flask. Which color change is seen in the mixture? Okay, so if more oxygen is forced into the flask, that means the concentration of the products is increasing. When the concentration of products is increasing, the reaction would be favored in the backward direction. The products are colorless, whereas the reactants are dark brown. So the dark brown gas will be produced in greater quantities. So option A, it becomes darker brown. Yes. Option B, it becomes paler brown. No. Option C, it turns colorless. No, because both these indicate forward reaction being favored. And D, there is no change. No, there is definitely change. So option A is the correct option for this question. Question 23. What is an observation of an oxidation process? Okay, blue copper sulfate crystals turn to white powder when heated. No, when you heat blue crystals of copper sulfate, they lose water, and the white powder is anhydrous copper sulfate. B. Copper being deposited on the cathode during electrolysis. Copper is deposited when copper ions accept electron to form atoms of copper. This is reduction. C. Green gas being produced at the anode when sodium chloride is electrolyzed. So we have chloride ions in solution that are converted into the green chlorine gas by removal of electrons. So removal of electrons is oxidation. So option C is correct. D. White precipitate forming when aqueous silver ions react with aqueous chloride ions. So when aqueous silver ions react with aqueous chloride ions, they join together to form AgCl, which is an ionic solid. within the solid, Ag still carries a positive charge and chloride still carries a negative charge. So this is not a redox reaction. So for this question, the correct option is option C. Question 24. An excess of aqueous iodide ions is added to acidified aqueous potassium manganate. Which row is correct? Okay. Iodide ions will undergo oxidation in the presence of potassium manganate. The color will change from purple to colorless for potassium manganate, whereas brown solution of iodine will be produced. So the reaction would be 2I minus forming I2. This is a reaction. The color of aqueous iodine is brown, but purple will turn to colorless. So overall, the color in the solution will be brown. So they've asked iodide ions are oxidized or reduced. They are oxidized. And the final color is not colorless, but rather brown because iodine in aqueous solution is a brown colored solution. So the correct option for this question is option B. Question 25. When ammonia gas is dissolved in water, a reversible reaction takes place. Which statements are correct? Ammonia is an alkali because it produces hydroxide ions in solution. Yes, definitely. The pH of this solution is 7. No, this solution contains hydroxide ions. The pH of this solution is definitely greater than 7 because it is an alkaline solution. So statement 2 is wrong. Statement 3, adding hydroxide ions to the mixture at equilibrium produces more ammonia. If you increase the concentration of hydroxide ions, which is the product, the reaction would be favored in the backward direction, resulting in more ammonia being produced. So statement 3 is also correct. So out of the three statements, 1 and 3 are correct, making option B the correct option for this question. Question 26. Three dilute solutions of acid, each with a concentration of 0.01 mole per dm cube, are reacted separately with excess calcium carbonate until there is no further reaction. The same volume of acid is used each time. The carbon dioxide produced is collected and its volume measured. All measurements are at room temperature and pressure. So here we have a table in which we have three acids, 1, 2, 3. The volume of carbon dioxide produced for acids 1 and 2, 1 and 3 is 20 cm cube, and for 2 is 40 cm cube. So basically, out of these three, acid 2 has a greater number of moles of H positive, and since the volume is double, that means it has got twice the number of H positive ions present. And another conclusion we can draw is the most acidic out of these three acid is acid 2 because it has got the lowest pH, and acid 3 is the least acidic because it has got the highest pH. So the question is asking us, what are the possible identities of acids? So acid 1 can be hydrochloric. Yes, it can be nitric, but it can't be sulfuric because sulfuric has got twice the number of H positive ions as hydrochloric or nitric. Acid 2 could be sulfuric. Yes, it cannot be nitric. It cannot be hydrochloric. And acid 3 being the least acidic could be ethanoic acid because ethanoic acid is a weak acid. And hydrochloric and nitric are not much weaker than each other. So the pH would have been closer to 2. So out of the four options, option A is the one with all correct acids present, making option A the correct option for this question. Question 27. The steps for the preparation of pure sample of sodium nitrate are listed. Okay. Titrate with dilute nitric acid until the endpoint is seen. 2. Evaporate to concentrate the solution. Okay, these are mixed up. Rinse out the conical flask, add indicator, pipette a known volume of aqueous sodium hydroxide into the conical flask. This should be the first point. Okay, so we are supposed to find out the order in which these are taking place. Okay, so what else? Cool and filter to remove crystals. This should be the last point. And if there are more points after this. Repeat using the same volumes of aqueous sodium hydroxide and dilute nitric acid, but no indicator. No, 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 no. Okay. So let's arrange this. Pipette a known volume of aqueous sodium hydroxide into a conical flask. Yes. Then we add the indicator. So this becomes option two or point number two. Then what do? We titrate with nitric acid until that end point is seen. Yes, because indicator has been added. Then we rinse out the conical flask. This becomes point number four. Then we repeat using the same volumes of aqueous sodium hydroxide and dilute nitric acid, but no indicator. Yes, indicator should not be present in the salt along with the salt. And then what do? We evaporate to concentrate the solution. Yes, to form crystals. And then cool and filter to remove crystals. Yes, this is our last point. So which order of steps is correct? So step one should be five. So A has one, B has three, C has four, D has five. So automatically D should be our answer. Let's just check. Then the second step should be four. Yes. Third step should be one. Yes. Fourth step should be three. Yes. Fifth step should be seven. Yes. Sixth step should be two. Yes. And the last step should be six. Yes. All are correct, making option D the correct option for this question. Question 28. A white compound is insoluble in water. Which cation and anion could be present in the compound? Sodium should not be present because all sodium salts are soluble. Calcium could be present. Carbonate could be present. Nitrate, all nitrates are soluble. So nitrate is not present. Okay, so sodium should not be present. So option C and D, which eliminates option A and B. Okay, calcium could be there, yes. Carbonate could be there, yes. But nitrate should not be there. So option C is the correct option for this question. Question 29. The flow chart describes the preparation of ammonium sulfate. Okay, so air provides us with element A, and this element is used in the Haber process. We need element 3 as well to form ammonium sulfate. Okay, so the element that we obtain from air is nitrogen, and Haber process also requires hydrogen. Okay, it's right hand side. Air provides us with element 2, which undergoes contact process to form ammonium sulfate. So in the contact process, air would provide us with oxygen, and another element required to take part in the contact process would be sulfur. So element 1 is nitrogen. Option C and D eliminated. Element 2 is oxygen. We continue with A and B. Element 3 is hydrogen. We continue with A and B. Element 4 is sulfur. Option B eliminated, making option A the correct option for this question. Question 30. Which row correctly shows the possible uses of sulfur dioxide and sulfuric acid? Okay, let's see. Sulfur dioxide is used as a bleach. Yes. It is used for killing bacteria in food. It is a food preservative. Yes. It is used in making detergents. No. In making fertilizers. No. Okay. Sulfuric acid is used as a battery acid. Yes. As a bleach. No. As a battery acid again. Yes. In making fertilizers. No. So we end up with option A having both the chemicals having their correct uses. So option A becomes the correct option for this question.